Okay, so now we're going to do an example problem. It's problem 12 from chapter 9, section 7 of the textbook. But again, more importantly, this is also an example of a midterm question. This was the second part of the first question on the Midterm2025 midterm from 2025. Okay, so this would be again about 10% of the exam, a pretty easy question. This is the first part of that question was using the gradient operator to do something. And now we simply have a question that exercises or tests our ability to calculate the curl and the divergence of a general vector function, okay, or a vector field. So this would be the problem statement. Compute the curl and divergence of f equals this. So f is a vector field. It's a function of x, y, z. It's 5y cubed I, 1/2 x cubed y squared minus xyj, minus x cubed yz minus xzk. Fine. So it's just some general polynomial type, sort of polynomial type vector field. So before we start, so we're asked to calculate both the curl and the divergence. So the first thing we just in our heads check, and you almost do this so fast after you've been doing vector calculus for a while, you don't think about it, but okay, can we calculate? Now, so the curl and the divergence are both operators that operate on a vector field, as opposed to the gradient, which operates on a scalar field and gives you a vector field. These are going to operate on a vector field and give you either another vector field, which is what the curl does, or give you a scalar field, which is what the divergence does. Okay, so that's what we're faced with doing. So we'll do the curl first. Okay, so I'm gonna leave this problem here, and I'm gonna do the solutions on the right-hand side here. So to start, okay, the curl of f. Okay, so in general, the curl of f, right, the way we remember this is we write a determinant, okay, with ijk unit vectors on the top row, the partial derivatives with respect to x, with respect to y, with respect to z on the second row, and then the components of the vector field whose curl you're calculating are on the third row, so this would be x component of f. Now right now, we can go ahead and put these values in. Now I didn't give myself enough room here, so let me just stretch this out a little bit, because I gotta fit this term in there. So, I don't know, let's put j over here, and k over here, die by die y, die by die z, and then here I write the components of f. So the first one I write the x component, so f y cubed. The second one I write this whole y component, which is 1/2 x cubed y squared minus xy. Right? That's that term. And the last one would be minus x cubed yz minus xz. Okay. So that's the configuration of the problem. Now we go ahead and we just kind of formally execute the determinant. Okay, so the first thing we would do, we'll do this will take up most of the space here, is we take this guy here, so I, okay, and then we take this and operate here, so we have minus die by die y, the minus sign comes from this minus sign here, of x cubed y z minus x z. And then we go minus die by die z of 1/2 x cubed y squared minus xy. That is the first term of the curl. Okay. The second term, you change the sign, so it's minus j, and I take x on z, so I go, and I'll put a minus sign up front because of that, so minus die by die x of x cubed y z minus xz, okay, minus die by die z of 5y cubed. Okay. And then finally, we have the k component. Okay. So I'm going to take x and y. So this becomes die by die x of this term here. This make sure, yeah, okay, just making sure I have the brackets right. 1, 2, x cubed y squared minus xy minus di by dy of 5y cubed. So we knew this from before, but the curl is always the complicated one. It's got the most pieces involved, right? You gotta be careful. That's why you don't want to try to do this quickly, overly quickly. It doesn't save you time in the exam. Number one. Number two, it's dangerous like to not write this. Like I can picture in my head, and I'm just gonna take I and then di by dy of this term and this term. It's easy to make a sign mistake doing that. Finally, it's also tempting to skip this step here. To just say, I'm gonna go I, and then do the derivative in your head, then minus do the derivative in your head. You can, I mean you can, but you don't gain anything by doing that, to be honest. So right now in my solutions, I do this kind of at the slowest reasonable pace, right? It's not wrong to do it faster, just might not feel qualified to do that. Okay? And what I'm gonna do is I'm gonna just replace this up here. And now we'll execute these partials. So this thing now would equal, okay, so I still have, I would take I, right, and I'll look like this. Okay, so let's do them one at a time. So di by dy, so we go through here, we'll have minus x cubed z, right? And then minus this term doesn't depend on y, so that's just that, right? Okay, oops. That was just the first part, and then I go minus, okay, di by dy z of the first term is 0, and then the second term is 0. This whole thing doesn't depend on z, so it's all 0. Okay. And this happens, well, in the problems we give you, this happens a lot, where sometimes the law terms just drop right out. And then we'll go minus j. Okay, we'll do this one. So now I got minus di by dx, so I got minus 3x squared minus 3x squared yz, yeah, and then I have plus z, and then I have minus di by dy z of 5y cubed, which is 0. That's all we have. And then I'll put the plus k on the next line here, slowly, di by dx, so I have 3 over 2 x squared y squared, 3 over 2 x squared y squared, yeah, minus y, okay, and then here we have a term here, so we have minus 15y squared, okay. So now, I mean, frankly, you're done, right? We will just, I see the lights kind of shining on this part of the screen here, but it's the time of day. So we'll just simplify this in one little shot, see if there's anything reasonable to do in terms of simplifying, but you don't have to do a lot. So sometimes there's some obvious things to do, but we'll just wrap it up with one more shot here. So this equals I, and I've got, yeah, minus x cubed z. Now I've got, sure, I'll change the sign, plus j z, oops, 3x squared yz minus z. Not sure that was really worth doing, but whatever. And then plus k, okay. And yeah, I don't know, I guess you could take a y squared out of part of this. So I think I did that in the solution. So you could go 3 over 2 x squared minus 15 y squared minus y. I guess, is that necessary? It's not necessary, but it's not wrong. Okay. And let's check here. So, and yeah, that's it. Okay. Now, when we just think about our answer for a second, just to make sure it matches what we would have sort of thought. It's hard to make sense of the terms. You can't really look at the terms here and go, oh yeah, sure, it's 15y squared. That doesn't really work. But we have to have a vector, right? It has to be a vector field. I's and j's and k's have to be here, right? You have to carry them through the calculation as you're going, not write them in at the end, right? That's, you know, sort of it. One little thing that comes up, people ask sometimes, and it doesn't matter, we've said this before, but just to be clear, when I'm doing the curl calculation, I often, because of the nature of the determinant, I write the unit vectors first. And so you see at the end, they go I times this plus j times this plus k times this. Whereas when we had the initial function, I said something I plus something times j plus something times k. It's the same. It doesn't matter. There are times where it may be natural to put the unit vector in front. There are times it's natural to put the unit vector behind. It doesn't matter, right? Which you do, as long as you're consistent as you go, right? Okay, so that's the curl. That's simple. Now, the second part of the question, okay, would be to calculate the divergence of f. And if you remember, the divergence are generally easier. There's just less moving parts in the divergence calculation. So I'll calculate the divergence of f. Okay, so it is the divergence of a vector field. Okay. The divergence of f, right, is always just I'll just write this really slow here just for a second. I plus j plus z k dot, then you have the f vector. So the point is, you take the x derivative of the x component of f plus the y derivative of the y component of f plus the z derivative of the z component of f, and you add them up. You don't have a vector when this is done. Okay? So this becomes then, right, we just have die by die, and I'll go kind of slow here, 5y cubed. And then we go, now there's no unit vector here. There's not I or anything. So you just go, okay, plus die by die y of this whole thing. 1 over 2 x cubed y squared minus xy plus die by die z of I hope I didn't confuse in the very last stop. We originally had die by die z of the z component of f. The z component of f was minus x cubed yz minus x. So I just took the negative sign and called this xz minus x cubed yz. Hope that's obvious, right? So that becomes this. Don't have to do that. Don't have to do that. Doesn't matter. Doesn't change the answer. Okay, and now you just execute the partials and add them all together. So. And again, right here, you can't have any unit vectors. At this point, we're just a scalar function. Okay, first one, 0, right? Because there's no x dependence on the x term of f of x, of f. So then die by die y. Okay, so now we have 2, so we're going to have, so plus x cubed y, right? Because it's 1/2 x cubed 2y, so that cancels off. And then minus x, right, die by die y. And then we just keep on adding, plus die by die z of this, so that's plus x. You might see what's coming here, die by die z of minus x cubed y. Okay? And that equals 0. Nothing special about that. Well, it is special. It means something about the vector field, but in the context of this problem, it is just what the answer is. There was nothing about the curl, obviously. There was no obvious thing about the curl that would lead us to expect the divergence to be 0 or vice versa. There are some deep things, but really, when we look at the problem, we just calculate them both. Now, the fact that the divergence of a vector field is 0 does mean something, and that'll make sense later on when we talk about divergence theorem. And the fact that the curl of the vector field is non-zero means something, and that'll mean something in Stokes' theorem and other things. So later on in the course, we need these tools because they become just parts of larger theorems, and that's why we're going to practice them now. But this phase is just a matter of execution. Okay? The final answer is 0, no way to expect that, but the big thing is it's not a vector. Okay? So that's it. That would be the part B of the first problem on the midterm. Again, the most common errors people make are not carrying their vector notation through the problem correctly. And sometimes just, it's sort of a similar problem to not carrying vector notation through. Sometimes they'll just start adding terms before they worry about carrying the unit vectors and try to add the unit vectors in later, and then they start adding things that shouldn't be added together. That's typical. But overall, it's pretty straightforward. Everybody does generally very well on these particular problems if you've been paying attention at all. Okay, so those two together, there's a previous recorded module I have on the first part, would be 1/4 of the whole exam, and the rest of the exam are just sort of more sophisticated concepts.